Have you ever really stopped to think about how our planet works? I mean, not just as a bunch of different places, but as one single, giant, interconnected machine. Well, that's exactly what we're diving into today, this idea of Earth as one massive system.
So let me ask you this. Is our planet just a random jumble of stuff, rocks over here, water over there, and all of us living things just kind of sprinkled on top?
Well, it turns out the reality is way more interesting than that. The source material shows that everything is connected. Our planet acts less like a random pile of parts and way more like a single, huge, living system. Okay, so to get our heads around this, we need to start with two basic rules that pretty much govern everything. One rule is for energy, and the other one is for matter. And this is a really key distinction. When it comes to energy, Earth is what we call an open system. Think about it. Sunlight comes pouring in, and then heat radiates back out into space. Energy flows through. But for matter, the actual stuff like air, water, rocks, it's almost completely a closed system. Besides the odd meteorite, what we have here is what we've got. It's all just getting endlessly recycled. So, if all this matter is basically trapped here, how does it all interact? Well, scientists have a handy way of breaking it down into four major parts, or spheres, that are always talking to each other. First up, you've got the atmosphere. This is that thin blanket of gas all around us. The air we breathe, the stuff that makes our weather, holds the clouds, and keeps the climate in check. Then there's the hydrosphere. And this is all the water. I mean, all of it. We're talking the giant oceans, the massive ice sheets, every river, every lake, and even the water that's hidden way down deep in the ground. Next, we have the lithosphere. This is the solid ground beneath our feet. It's the continents, the seafloor, all the rocks and soil. It's literally the foundation for everything else. And finally, there's the biosphere. Hey, that's us and every other living thing, from the tiniest little microbe to the biggest blue whale. And the really important part here is that the biosphere isn't separate. It's constantly interacting with and changing all those other spheres. Right, so these spheres aren't just sitting there next to each other like neighbors. They are constantly swapping stuff back and forth. So let's take a look at how that matter, the stuff in our closed system, actually moves between them. And the water cycle is the perfect example of this in action. It's the classic case study for how matter moves between the hydrosphere, the atmosphere, and the lithosphere, physically connecting the whole planet. Let's just quickly trace its journey, right? First, the sun heats up water on the surface, and it evaporates, turning into vapor and rising up into the atmosphere. Up there, it cools down and forms clouds. Then, that water falls back down as rain or snow. That's precipitation. And finally, it flows over the land as runoff, making its way back to the rivers and oceans to start all over again. It's this incredible, continuous loop. But hey, it's not just the fast-moving stuff like water. The very ground we're standing on, the lithosphere, is also part of a cycle. It's just happening on a much, much slower timescale. We're talking millions of years. And this is the rock cycle. So, rocks get broken down by weather. Then erosion carries the little bits away. That sediment gets dropped somewhere else, and over millions of years, heat and pressure can squish it and cook it into totally new kinds of rock. It might even melt completely before solidifying again. It is literally a planet-wide recycling program for the land itself. Okay, so we've got the spheres, and we've got the cycles moving matter between them. But what's controlling all of this? What hits the gas or pumps the brakes on these cycles? The answer is something called feedback loops. And these things are like the invisible engine of the entire Earth system. So what is a feedback loop? It's actually pretty simple. It's when the result of something happening circles back around to influence that same thing to happen again, making it either stronger or weaker. It's a cause and effect chain that feeds on itself. And they come in two main flavors. You've got positive feedback loops, which amplify change. They push the system further and further in the same direction. Think of a snowball rolling downhill, getting bigger and faster. Then you have negative feedback loops. These are the stabilizers. They push back against a change to try and restore balance. You really need both for the planet to work. I know, this can sound a little abstract, so let's use a really powerful real-world example to see how this works: melting sea ice. All right, so here's a classic positive feedback loop. Let's say things warm up a bit, and some of that bright, reflective sea ice melts. Well, that exposes the darker ocean water underneath. And since dark surfaces absorb way more sunlight than bright white ice, the water heats up even more, which, you guessed it, melts even more ice. See how it's a runaway train? The initial warming gets amplified.
And that brings up a really good question. If you've got these powerful loops that just amplify change, what stops the whole planet from just spiraling off into some crazy extreme state?
Well, that's where the negative feedback loops come in to save the day. They're the balancing act. Let's take that same starting point, warmer water. Okay, so that warmth also causes more water to evaporate. More water vapor in the air means more clouds can form. And what are clouds? They're big, white, and reflective. They bounce sunlight back into space, which creates a cooling effect that counteracts the initial warming. It's the system pushing back. So when you put all of these pieces together, the spheres, the cycles, and these competing positive and negative feedback loops, you start to see our planet for what it is, this incredibly complex system, always in a delicate dance to find balance. And this is a dance that we are now a huge part of. Our actions are creating new inputs into this ancient system. For instance, the source material points out that when we clear plants from an area, the bare ground left behind is usually darker, so it absorbs more heat from the sun. That one simple change creates a warming input, which can set off its own chain of feedback loops. And this really brings us to the big takeaway here. When you start to see Earth as this one big interconnected system, where matter doesn't really leave and every action can trigger a cascade of reactions, you have to ask a pretty profound question. What is the true, full impact of our very next step?